Okay, let's do a quick video on light sensor. This is a basic light sensor circuit. Now I have done tutorials on opamps, voltage divider, and the introduction to the basic circuitry already. These circuits are generally taught in grad schools in first year because it's quite simple and it's analog. Analog circuit is something which deals with simple waves, not digital wave. Waves are like 0 and 1 only. So this circuit generally uses the analog inputs and converts this into a level triggered output which is either 0 or 1. Actually this is a partially digital to ADC, means analog to digital converter type of project, but this is a good light sensor project. Let's see how this works as a light sensor. Here this is a pod potentiometer. This is calibrated according to our need, what voltage we want to give it to the reference to the input of this output. As I've already done the tutorial on op-amp, the op-amp just recognizes the difference of the difference of the voltage V1 minus V2 and amplifies it by a factor of A can be equal to 1000 or more than that. So even if a small change in this input comes, the output is just 5 volts or either 0 volts. So suppose we keep this port to 4.9. This is 5 volt supply. Suppose we keep this port to 4.9. Let's make it another diagram. So if we keep this as 5 volt supply, and this is calibrated according to our need. This is connected to one terminal of op-amp. Then another terminal is connected to the LDR. LDR is light dependent resistor. Obviously we need to have something like that, because without that we cannot realize the sensor. What we are sensing? Light. So we have to have something which is related to light, sensing light. So here it is, LDR. LDR is kept here again across 5 volts. And another important thing is this resistor. If we don't keep this resistor, then always here the voltage will be 5 volts, because I have shown in the tutorial, if you want to refer it, that if we supply 5 volt and open this terminal, then here the voltage becomes 5 irrespective to this resistor here, and here voltage is always 0. So if we will not provide this resistor and simply connect directly, then we will always 5 volt. So there will be nothing to compare. So here we have calibrated some voltage we need, suppose 3 volts, and another voltage coming between the voltage divider circuit of LDR and R, and the output is simply connected to an LED. Now when the difference of temperature light falls on this, suppose it is set for 3 volt. Suppose the voltage here is 3 volt. This resistor is around 10k, because this LDR has a resistance of 10k, around 10k to 50k resistance. LDR is actually for bright, it has very low resistance, and for dark it has high resistance. It's good basic thing about LDRs. So suppose in a room in a normal room where light is coming on this LDR, and we have set this pod in reference with this, I mean no difference of voltage is here, 3 volt and 3 volt. So what will happen here? Nothing. 0 volt. Yeah, 0 volt, because both inputs are same. V1 minus V2 times A gives the gain output. So V1 minus V2 is same, so it will be 0. So if some differential light falls on this other than the normal light for which we have calibrated this, then something good happens. The resistance of this thing will change, the voltage around this thing, distribution of voltage, the division of voltage which we have done in previous videos will change, So we'll get a slightly less than or more than voltage here, suppose 2.5 or 3.5. For 3.5 and 3, what will happen? 3.5 minus 3 will get 0.5 volt times the magnitude of gain. We'll get something, we'll get 5 volts because A is quite high and it saturates. If you want you can just refer to the tutorial on opamps. It says quite how this saturates. It's 0 volt or 5 volts because op-amp can give output between 0 and 5 volt. There is no output more than 5 or less than 5. This is the basic principle because supply is VCC 5 and the ground, so either the output is 5 or less than 5. Doesn't mean that you have gained 1 lakh of, if you have a gain of 10,000 and you're providing 1 volt and you expect 10,000 volts. It is not possible. 10,000 volts is even not possible on big transmission lines. So it's quite sensible or logical that output will be between 0 and 5. So what we have learned that the differential output from LDR and the pod is sensed here, and it is just amplified by a big factor. Since the amplification is very big, the small changes in the voltage is just converted like this: LED on, LED off, LED on, LED off. So small change in light around LDR will be transferred to an on-off state machine. So let's see how it works. So here's the circuit which I have made. This is 5 volt regulator because the battery supply is 9 volts, so we need this regulator, otherwise the IC will burn, nothing will happen. And this is middle thing from coming out. This regulator is ground, so ground is given to ground of the IC. VCC of the IC is connected to VCC of the supply. 10K port, ground, VCC. This is the middle thing which we need. Middle, the point, the contact point which goes to the comparator number pin 1. Then this LDR from across this resistor which we discussed in the diagram is here. If I put my finger on the LDR, what will happen? Light falling on it will differentiate, so it will create a dark environment around the LDR and its resistance will increase. So let's see what happens. Oh, it's working. See, what I did was just block the light coming on the LDR. The resistance of the LDR will change. This resistance change will appear as a voltage change, and this voltage change will be amplified on the LED. So here's a simple light sensor which you can make at home.